Our universe is remarkably intelligible. Over the last few centuries, we have uncovered a wondrous realm of mathematical laws that undergird the entirety of space and time. But from where do these laws come? Physicist Alexander Vilenkin asks, quote, "In the absence of space, time, and matter, what tablets could they be written upon? The laws are expressed in the form of mathematical equations. If the medium of mathematics is the mind, does this mean that mind should predate the universe?" End quote. Welcome to the Atheist and Christian Book Club. Our guest this month is author and director of Discovery Institute in Seattle, Washington, Dr. Stephen C. Meyer. On this month's club meeting, we discuss with Dr. Meyer his latest book, The Return of the God Hypothesis, and examine the evidence in both cosmology and biology for a mind behind the universe. Christians affirm that God created the heavens and the earth and everything they contain, including biological life. Atheists affirm that nature is likely all there is and that design in the universe is illusory. So is there a mind behind the universe, or is that idea just a product of our minds? Come and see on this month's edition of the Atheist and Christian Book Club. Here is the co-founder and host of the Atheist and Christian Book Club, Watchman Fellowship President James Walker.
Welcome to the Atheist and Christian Book Club. We are a monthly gathering of believers and skeptics respectfully discussing important books from both perspectives. My name is James Walker. I'm co-founder of the book club. I'm also a Christian apologist with Watchman Fellowship, an apologetics Christian organization focusing primarily on interfaith evangelism. Our other co-founder is Bill Cluck. Bill Cluck is a former Christian, now atheist, and a friend of mine for going on 5 years now, I think.
Yeah, so, it's been great.
Yes. Huh. Yeah, and a good friend, I would say. So, Bill, yes. Welcome back to the club again. And we've got a room full of guests coming in and a great guest author. And
absolutely.
I just wanted you to take a moment, if you will, to talk to us about our guest author today.
Yeah, Stephen Meyer graduated from Wentworth College, where he later became a professor there. Then he worked for Atlantic Richfield here in Dallas. So he does have a Dallas connection. And one of the seminal events in his life was in 1985. He attended a conference right here in Dallas, and he saw that evolution might have some question marks, that some of the guys that were former atheists were questioning the neo-Darwinian model. So then he decides that, the job thing isn't for him. He spells Jobdia like I do. And he applies for a Rhodes Scholarship to Cambridge University. Sadly, a Miss Texas beats him out. So, as much as Stephen Meyer's done, he has to wait a year. But then he does get a Rhodes Scholarship, goes to Cambridge, and gets a PhD in the philosophy of science. Now he's at the Discovery Institute in Seattle, Washington, and has published many books. I remember reading Signature of the Cell, which is a very comprehensive book, very enlightening, at an airport, and which is where you want to read because it takes time. He also, one of his big books is Darwin's Doubt, which casts light on the problems of Darwinian evolution. His latest book is Return to the God Hypothesis. And he's interviewed by our own Daniel Ray, who did a great job, and which I really enjoyed because it was telling Stephen's personal journey through faith. Also, he one of the real interviews I enjoyed were two. One was the guy in London. I've skipped the name now, but Justin Briley, unbelievable podcast, and he was interviewed, or the other side was the fellow Marshall, who was a paleontologist who wrote a review. And Stephen, one thing I liked about Stephen Meyer is he was like, bring it on, let's talk, let's get this out in the open. And that's what we're about in the book club, is let's bring these things to the open, let's look at the evidence and see where it goes. So and the other interview, which was very interesting, was Michael Shermer's, where Michael said, hey, let's not have a big debate and go at each other, let's just look at the evidence, look at each other's views. And I thought it was a very pleasant interview, and hopefully, he can do more of those because I really enjoyed it. But that's Stephen Meyer, and really looking forward to having you, Stephen.
Bill and I have talked informally over coffee about some of the influence that your earlier book, especially Signature in the Cell, has had on him. So we're really excited about being able to talk about the return of the God hypothesis. Welcome to the Atheist and Christian Book Club, Stephen.
Well, thank you very much, and thank you for all of you from the various diverse perspectives represented here. This is a very exciting kind of way to do a book club, I think. So thank you. I'm glad to be invited. Daniel said I should kind of dive in and give a little thumbnail of the book, and then we just open it up for questions, or do you want to?
Let's do this first. I'm going to let Bill kind of ask the first question. But after you're able to give a kind of an intro to the book and a little bit of background. But I did want to take just a moment, if I could, to talk about what we have coming up, just so we can kind of get that. Last month, our guest author was Lawrence Krauss. We discussed A Universe from Nothing. Very good conversation on that. For those who missed it or want to get the video, it's now up at atheistchristianbookclub.com. You can watch that one along with the last maybe 2 years or so worth of book clubs, and I want to encourage you to do that. Next month, our guest author is going to be Bart Ehrman. Bart Ehrman is probably the preeminent skeptic, New Testament critic, textual critic of the New Testament, expert in Christian origins and development, also on historical Jesus. He's written on that, a book I quite enjoy. But he is coming from an agnostic atheist position. He is a former evangelical. He went to Moody, went to Wheaton, sat under preeminent New Testament scholar Bruce Metzger. But somewhere in that journey and throughout that education, he lost his faith in the Bible ultimately, and then in God eventually. And he's going to be sharing with us probably his best-selling book. This is the third book we've dealt with Dr. Ehrman, Misquoting Jesus. Now, as I shared last month, we're excited to get Dr. Ehrman, but this is something new to us because there is a speaker fee involved, and we have not done speaker fees before. The most we've ever paid a speaker, and we're willing to match that with you, Dr. Meyer. We have given a pound of coffee to one of our guest authors, and we'd be more than happy to match that with you.
I heard it was a pound of flesh in the.
A pound of flesh. No, that's what we get in exchange for the coffee. So, what we're doing on that is we are trying to raise some money for that, and he doesn't come cheap. So if you want to help out and believe in it is for 2 hours, $2,000. And if you want to help us to do that, if you're part of the book club, believe in what we're doing, if you go to watchman.org/Bart, you can make a donation. Now, we've already raised some of the money. We've got about 20 minutes of Bart Ehrman already raised. So help us raise the rest of it. And if you do that, it will be tax deductible. And you do need to know, This really doesn't go to Dr. Ehrman's pocket. All his speaker fees, not just this one, but everything he does all year long, speaker fees, is donated by Dr. Ehrman to charity. So it goes to good causes, and we want to make that possible if we can do that. So in the meantime, we're so glad to have be talking about return of the God hypothesis and have Dr. Meyer with us. And I am going to ask, or allow, hopefully, to have a good question from Bill Cluck on that. I know he has some that he's been wanting to ask you for a long time. But before we get to that first question, and I did want to say, if you're here for the club, we've got about close to 30 people, I think, in the room already, and we'll get more as the evening goes on. You want to ask your question, then if you will go into the text and put that, briefly what your question is, and then Daniel Ray or Brady Blevins, they're kind of helping to moderate. They will call you up. We'll ask you to unmute your mic and come on and to ask your question. I do want to remind everyone that this is a respectful conversation. That these kind of issues, when you get atheists and Christians together in the same virtual room, it can be like cats and dogs. We know that. So we're going to ask everyone to be on your best behavior. Pretend like you like the person. Ask your question. Now we do like tough questions. I don't pretend like you agree. So go ahead and ask tough questions, but let's do it politely, and we will all appreciate that, and I think get a lot more out of the conversation tonight if we do. So with that, I'm going to ask Dr. Meyer, could you just take a moment to, most of us have read the book or read at least part of the book. Some of us have watched the 2 interviews that Daniel Ray did with you for our podcast. And but there are some people that just heard about this today. They haven't had time. Can you just give us a little background on what motivated you to do the book, kind of the 3 different kind of, what is the God hypothesis, and what are the new developments that have made this, put this really back on the table for discussion from your perspective?
Thank you, and thanks for having me on. One little known fact about me is that at least a while ago, when Bart was still publishing with Harper One, I think he still is, we had the exact same editor. So that was kind of, and I've never met him, but oh,
that's neat.
In any case, that's a connection. And here's another one. Early in my career, I was working as a geophysicist doing digital signal processing for a Dallas-based oil company. As an undergraduate, I'd done physics and geology. I'd done a double major, but I took a lot of philosophy, a minor. And a conference came to town, which I discuss in the book, which might have had a very similar sort of inspiration as to your book club. It was called Christianity in the University, an International Conference of Atheists and Theists. And it was organized around 3 big questions: the origin of the universe, the origin of life, and the origin and nature of human consciousness. And I had, because of my academic background and just my native interest from the time I was a young teenager, been very interested in questions at the intersection of science and philosophy. And so when I heard about the conference, I decided I had to go. I walked in kind of off the street, paid my admission, and listened initially to an amazing discussion about modern cosmology that had on the panel Donald Goldsmith, who was Carl Sagan's science advisor at the time on the atheistic side of the panel, and Alan Sandage and Robert Jastrow and Owen Gingerich, who were all speaking on the theistic side of the panel, though Jastrow was still at the time considered himself an agnostic, but he thought the evidence was pointing in a theistic direction. In any case, there was a talk at the conference by Sandage who shocked a lot of people by climbing up the stairs and then sitting with a theist on the side of this, is a binary division of speakers. And Sandage proceeded to explain the evidence for cosmological singularity. He discussed the evidence of fine-tuning, and he talked about how this evidence had, among other things, moved him from a theistic position as a longtime agnostic Jew to a belief in God, and eventually he went even to a full Christian conversion, and that's what he announced at this conference in 1985. The next panel was a discussion of the problem of the origin of the first life. It featured 3 or 4 scientists who had recently come out against chemical evolutionary theory, and were exploring the idea, very incipient idea at that time, of intelligent design, though they didn't call it that. They said that they thought that the information-bearing properties of the large macromolecules inside living cells, even the simplest living cells, suggested perhaps that an intelligence or an intelligent cause had played a role in the origin of life. Anyway, this was a very interesting event, and one which definitely intrigued me. It seemed to me that in all 3 panels, including the one on the nature of consciousness, that the materialist side was on the defensive, and the theistic side actually had the intellectual initiative. I'd gone to a rather small Presbyterian liberal arts college. I probably had the same intellectual insecurities as most young Christians coming out of environments like that. And I was pretty much blown away by what I heard, that it seemed that there was, at the very least, a spirited discussion between the materialists and the theists about these big questions that deeply interested me. And that was, in a sense, the germination of my interest in the big question of what science can or cannot tell us about the reality of God, or what we might call the God hypothesis. I went to grad school a year later to Cambridge. One of the people that I met at the conference, Charles Thaxton, was a co-author of the book, The Mystery of Life's Origin, which was a really detailed, interdisciplinary, and quite compelling critique of contemporary chemical evolutionary theory, the idea that life arose from simpler. And in the epilogue to that book, he and his co-authors floated this idea of what we now call intelligent design, that the properties that we're seeing of even the simplest living cells in the exquisite digital nanotechnology and the information technology present there are hallmarks of intelligence, and therefore attempting to explain the origin of life absent what they called an intelligent cause was a fool's errand. I was intrigued with this idea, not completely convinced, and a year later I found myself beginning a program in the history and philosophy of science at Cambridge University. I did, in my first year, a master's course that included a short master's thesis on the origin of life problem, and then went on to do a PhD in origin of life biology within that interdisciplinary program. And during that time, became progressively more intrigued and eventually convinced by what we could call the design hypothesis as an explanation of the origin of the first life. So that's a bit of the background as far as my story and how my interest in these questions germinated. As far as describing the book, and I do tell a bit of that story in the book, I would frame the discussion a bit differently by invoking one of my favorite new atheists, and that's Richard Dawkins. The other being Lawrence Krauss, whose interactions have been, for me, heuristically valuable. They've spurred me to new study, new insights, and but anyway, I tend to really appreciate the aggressive new atheists who care enough about the reality of the question, the truth of the question, to take a firm position. And I've always appreciated Dawkins in particular for his talent at framing the key issues. And in the 1990s, he wrote a book where he has a fantastically clear quotation that I think beautifully frames the issue before us tonight, and the issue that I addressed head on in my book, in which he said, the universe has precisely the properties we should expect if at bottom there is no purpose, no design, nothing but blind, pitiless indifference, which of course is shorthand for his worldview, the idea of scientific materialism, that matter and energy have been here forever. They're eternal and self-existent. They are self-organizing. and therefore self-creating, and we can explain the appearance of design in life and in the universe as a result of these purely unguided, undirected natural processes. Dawkins is an ardent scientific atheist, but underlying scientific atheism is a worldview that's shared by many agnostics as well, who are essentially functional atheists, and that worldview is in scholarly circles known as scientific materialism. The idea that matter and energy are the things from which everything else comes, in the same way that in a theistic or Christian or Jewish worldview, God is the thing from which everything else comes, the eternal, self-existent thing. And every worldview has to, or inevitably, posits such a primitive or ultimate explanatory principle. So in any case, back to the Dawkins quote, I think he does a beautiful job of framing the issue. Does the universe, let's pose it now as a question, does the universe have precisely the properties we should expect if at bottom there is no purpose, no design, nothing but blind, pitiless indifference, no mind behind the universe, a matter first rather than mind first view of reality? And in my book, I accept that framing. I think it's a beautiful way to frame the question, but I contest the answer to the question that Dawkins gives. I do not agree that the universe has precisely the properties we should expect if at bottom there's no purpose, no design. In other words, if scientific materialism is true. Instead, I argue that the properties of the universe that we have, in particular, the properties that we have relevant to the crucial questions of biological, physical, and cosmological origins, are precisely what we would expect given a prior theistic worldview. And therefore, I argue that theism provides an overall better explanation of these key properties or discoveries that modern science has made about the origin of the universe, the origin of its beautifully finely tuned structure, and also the origin of life with its exquisite realm of digital nanotechnology, the information-bearing properties of large biomacromolecules, and the whole realm of miniature nano machinery that we find in living cells. And I argue that that three big discoveries are not at all what we would expect on a naturalistic or materialistic worldview. The first of those discoveries is the discovery that the universe, as best we can tell from both observational astronomy and developments in theoretical physics, had a beginning. And secondly, that the universe has been finely tuned from the beginning or soon thereafter against all odds and for no underlying reason of fundamental physical theory to make life possible in the universe. And thirdly, that life contains, even the simplest living cells contain a realm of information and information processing technology that display all the hallmarks of intelligent agency, hallmarks that we know from our uniform and repeated experience, suggesting that life itself is the product of some kind of master programmer. And so I look at each of these three discoveries. I show that intelligent design, and indeed a design hypothesis that posits an agent with properties or attributes that, for example, traditional theists such as Jews and Christians have long ascribed to God, that such an agent best explains the three big discoveries that I just outlined, that the universe has a beginning, that it was finely tuned from the beginning, and that we have seen big infusions or bursts of new information in our biosphere long after the beginning. I then also argue that these are not discoveries that would be accepted or expected on a standard scientific materialist or naturalist point of view. And in fact, I allow the scientific naturalists, materialists, and new atheists to help me make that case, often by telling the stories of people, scientists who hold that worldview or held that worldview, who found these discoveries so shocking that they either changed their point of view or had to develop extremely convoluted and unparsimonious explanations for these different discoveries. And in the latter part of the book, as I address objections to my positive argument for the God hypothesis as the best explanation for these three key discoveries, I then look at challenges and objections to that argument. And one way in which I refute those challenges is to show that the alternative explanations that scientific atheists or materialists have had to propose have inevitably resorted to extremely abstract, very convoluted and complicated and unparsimonious combinations of postulates that at the very least fail the test of Occam's razor, but also have other internal problems that suggest that they are not good explanations. They either lack causal adequacy, or in some cases, in the postulation of things like multiverses, for example, they have their own hidden implicit theistic implications. And we can get to that in the discussion. So the structure of the argument is that that there are two basic competing worldview explanations for biological, physical, and cosmological origins, that one has clear explanatory power by reference to what we know about how agents work. The other lacks that explanatory power, and to compensate for the absence of that explanatory power, scientific naturalists have had to posit things like multiverses, alien designers, phantom fields, and they've had to posit or construct elaborate mathematical constructs or formulations in order to try to explain the origin of the universe by reference to physics before there was any physical universe, which is what I take the quantum cosmological research program to be doing, which I think at bottom is either has its own theistic implications or it's deeply contradictory. So this is an assertive argument. I'm not a tentative theist. I'm a very convinced theist. I think that scientific materialism and naturalism is on the defensive, and you can see that by the nature of the alternative hypotheses that are being proposed to try to explain these basic discoveries, which are precisely what theists would expect and not at all what scientific naturalists would expect. So I'll leave it there and open it up for what I'm sure will be a very spirited discussion.
Well, thanks a lot, Stephen. Appreciate that. Now we might end up having to have 3 book clubs now, but we'll try to cover as much of this as we can. But each of these were fascinating conversations and discussions we'd like to have. I did want to get Bill Cluck, our atheist co-founder, the privilege of having that first question. And you haven't told me what your question is, Bill. So
well, I have 2 questions, but
okay.
The devil's in the details. Okay. So I'd like to introduce you to my great-great-grandfather, Pakicetus, and his, grandfather, Ambulocetus. You're familiar with well evolution, right, Stephen?
Oh, yes, I've written about it with Gunter Beckley in a long essay. Yeah.
Well, we had David Berlinski on, and one of his problems was how do you go from Pakicetus, which looks like a little calf, to hanging around the water, and then all of a sudden you're able to stay underwater, you're able to filter salt water. One of the most compelling things I found about your book was, first of all, I was kind of blown away that the DNA, it's not the chemical makeup like ink on a page, it's the order of the nucleotides that the cytosine, the guanine, that determine the proteins and so forth. And even I was talking to Daniel in his interview, and he said, well, it gets even worse. You have genetic regulatory systems that turn on and off and regulate the DNA. So let's go back to the will of evolution, but first tell me why you think that's compelling, the genetic regulatory systems.
Well, I've got a colleague, Douglas Axe, who did his PhD in chemical engineering at Caltech, but did a PhD thesis that was essentially in protein science and therefore molecular biology. And as he was studying, for example, just the simple lac operon regulator, which is essentially a kind of molecular thermostat. It's got a perfect engineering feedback loop. And, he's studying in an engineering department at Caltech, and he goes to his supervisor and he says, look, this is obviously a design system. What do the biologists say about this? And his PhD supervisor says, well, I know that, and you know that, but you can't say that to the biologists. It's against the Darwinian orthodoxy. And that was his first intrigue. Molecular biology is just awesome to behold. And it isn't, I think, in many cases, just the term intelligent design floating out there in our informational space has turned many PhD students into molecular biologists our direction. We get them every summer with our summer seminar, because you're not only dealing with digital code, and you're right, and this is a very important point, and maybe I should elaborate on that first, is this goes back to a brilliant paper by Michael Polanyi in 1967 and another one in 1968. One published in Science, one published in Chemical Engineering News, explaining that the sequential arrangement of the nucleotide bases on the DNA cannot be explained by the underlying chemistry. This was a huge idea in Origin of Life studies. It's still flogged today. The idea that DNA is basically like a crystal of salt or crystal, where the forces of attraction between the constituent parts account for the sequential arrangement that constitutes the information. But and I know you've looked at the book, so thank you, but there's a section where I reprise a deeper treatment of this issue from Signature in the Cell in the new book, Return of the God Hypothesis, showing that if you look at the structural formula for DNA, you can see that the forces of chemical attraction are not responsible for the sequential arrangement of the bases that constitute the information. And so Polanyi wrote these two articles in the late 60s called Life Transcending Physics and Chemistry. And this has had profound implications for all attempts to explain the origin of life on the basis of underlying self-organizational principles of attraction or mutual chemical affinity. And there's a similar problem with explaining the origin of the code as well as the origin of the genetic text. I won't go into that, but it's also in Signature in the Cell. And so that's one thing, just explaining the arrangement of the characters that give it the function that allows it to specify the production of the proteins. But then you have to recognize that the DNA is also part of a complex information storage, transmission, and processing system that encodes information for proteins that in turn are necessary to read the information on the DNA. So you've got a classic engineering closed loop. And then beyond that, you have an entire overlay of regulatory RNAs and a regulatory system that determines which parts of the DNA are expressed at any given time. And one of the things we found is that the so-called junk DNA that was still being flogged as an argument against intelligent design as late as 2009 and 2010, and 10, has now been definitively discovered to perform important functional roles, specifically the role of regulating the timing expression of the DNA, of the coding regions of the DNA. So you have something like an operating system directing the expression of coding files. So this is a super, super tightly integrated information storage and processing system, and it has utterly defied attempts to explain this by reference to underlying chemistry or chemical evolutionary processes, such as been long invoked in the study of evolutionary abiogenesis.
Yeah, and you made that point beautifully. So how do I get to my great-great-grandfather from land-dwelling Pakicetus to Amblicitus, Brachiocetus, and then they're the evolutionary precursors of the tetrapods, the dinosaurs. Is that right?
Well, allegedly. And the question is, within the ID movement, we have people who do and don't accept universal common descent. I think everyone accepts some diversification within certain taxonomic categories. I wrote a piece with Gunter Beckley, the German paleontologist who's come our way on the ID question, and not just about the Cambrian explosion, about which I wrote a whole book, but about 17 major fossil explosions that are documenting major morphological innovation in the history of life, as opposed to small scale and more minor variation, which none of us dispute. So there's a kind of open question that ID people are quite willing to investigate, pro and con, which is how wide are the envelopes of variability that we might map in the taxonomy of life? Do we have one big tree, or do we have a lawn, or do we have a number of trees representing, for example, the higher taxonomic groups, which don't all marry up into one big tree? So do we have a monophyletic or a polyphyletic geometry in the history of life? My perspective and inclination is to be monophyletic at the lower taxonomic levels, but polyphyletic at the higher ones. And so that means there are some things in between where I think you've got some real open questions. But here's one thing that I'm really interested in about the whale evolution story, okay? I've never been totally persuaded by just similarities in bones, because there's so much more to organisms than bones, as the internal organs, as you mentioned. And one of the really big problems is that and I wrote about this, and Beckley is much more of an expert on this than I am, but one of the really anomalous aspects of this well-told story about whale evolution is that the anatomical distinctives of aquatic mammals emerge very quickly in that sequence. It's within 3 million years max, okay? And we have a project going on right now called the Waiting Times Project, which is a research project we're supporting with really top flight mathematical biologist at the University of Stockholm named Ola Husra. He does a lot of population genetics work and has developed very sophisticated population genetics models. And he's working with Beckley and Richard Sternberg on this whale evolution question, also Ann Gager, another of our molecular biologists. And when you begin to quantify what Berlinski first floated as a kind of very interesting intuition, which is that you've got all these distinctive anatomical structures and features in aquatic whales that you don't have in their nearest putative land-dwelling ancestors, you've got a real problem thinking about how those different systems could have emerged so quickly, because many of them have many functionally integrated parts as part of the overall anatomical innovations, or just anatomical innovations. And you can do population genetic modeling on how many coordinated mutations would be required to produce, for example, the internal testes of the male whale, or the protection against the breathing of salt water, or the dome that the aquatic mammals have on their head with the very specific proteins that give that insulating material and the ability to transmit the sonar. So many morphological innovations. And these innovations are absolutely, as a prerequisite, require multiple coordinated mutations. They can't be built as a result of a few point mutations. There's way too many integrated systems involved. And so there's this problem in population genetics where if you require, with each new mutation that needs to be part of a coordinated set, the waiting times using basic Darwinian math rise exponentially. So if you need one mutation, no problem. If you need two, no problem. If you need 3 or 4 and they don't need to be coordinated, no problem. But if you need coordinated mutations to build an anatomical innovation, then the waiting times rise exponentially. And almost all of these innovations that are associated with the whale sequence, and the ones that are the distinctive anatomical characters that mark it as aquatic, these produce waiting time problems that are beyond geological time in some cases. And so they have a new paper out with the Journal of Theoretical Biology. I think Sternberg did some of the background research on this. His name will be on the next paper, but there's a whole sequence of research papers coming out on this. And so that's a really big question that's unanswered. Are these anatomical similarities superficial, the bone structures, the little things that we might say are feet or whatever, or do we have a true discontinuity? From the standpoint of the Darwinian mechanism, I think it looks like we do have a true discontinuity. Was there some sort of hopeful monster type of macro mutation? I don't know, but I think some of these stories that have been part of the staple of evolutionary narrative are going to need reevaluation in light of the very precise mathematical analysis that's being brought to bear on the requirements of true genetic and morphological innovation. So I think there's an open question there, but I think some of our researchers are attacking this in a new way that I think is at least going to raise some profound questions about the creative power of mutation and selection.
That's a beautiful answer, but here's my really big problem. I used to follow Hugh Ross, progressive creationist, where God comes in at certain times, here's the problem. For 3.5 billion years, you have prokaryotic bacteria. It takes, let's just assume God intervenes and you have this transcendent intelligence. 2.5 billion years ago, you have eukaryotic bacteria where you have a nucleus and organelles. So it's taken God 1 billion years to get a nucleus and so forth. Then from 2.5 billion years to the Cambrian, which is the ace card for the creationists, 520 million years, you have all these new phyla suddenly appear. You have brachiopods and sponges and trilobites. I mean, God has a thing for trilobites. It's like
I got one behind me. I do too.
Oh, do you? Okay.
Yeah, I've been fascinated since childhood.
And there's like 100 species of trilobites, right?
Yeah, and it's a completed inverted cone of diversity as well. You get the major body plan arising first, and then you get the variation on the theme within the limits of the, it's not the bottom up picture that you'd expect on Darwinism. It's a top down picture that's similar to the kind of mapping we would do of innovation in our own history of technology. You get a basic bow plan, for example, of an automobile, and then you have the variation on that theme where the basic structure of the automobile, four wheels, 2 axles, a chassis, that remains the same, but you get all kinds of variations on the theme. And that's the pattern we see in the fossil record. Abrupt appearance of major groups, variation on the theme within the constraints of an informational data set or genomic reservoir. But to me, that looks like design at a number of levels. Why the design? Now, your question though is different. It's why did the designer take so much time in between innovation?
Well, and here's the key question, Stephen, is then you have these extinctions of the trilobites. He took so much time to create all these trilobites, and you have the Permian extinction 200 million years ago. Then you have dinosaurs for 200 million years ago, and then you have the KT barrier where the meteorite hit, and he blows all them out the water. And then here's what they asked, the big question at Reasons to Believe. And Foz, one of the people on Hugh Ross's staff, asked, if man is the crowning achievement, God's crowning achievement, his end goal, why in the world did he take so long to have man?
Well, I have a short answer for that, and that is divine extravagance. I think that this is, interestingly, in the response to my book, I have had almost zero pushback on my critique of the multiverse, my critique of quantum cosmology, my case for intelligent design based on the information-bearing properties of DNA. The questions that I've gotten have been much more of these sort of meta-level, why would God have done it that way questions? Right. And these are philosophical in nature. And I personally think that the size and grandeur and beauty of the universe is actually a testament to the extravagance of God and the creativity lavished on the human race. Many young Earth creationists, of whom I am not one, will ask me, well, why did God create the dinosaurs? And my answer is for the endless amusement of 4-year-old boys millions of years later. I mean, there's wonder in this world.
Right.
And I think that's, there's this whole problem in Darwinian evolution. I've got volumes and volumes from Bernard de Brera, this great butterfly expert from the British Museum. There's so many gorgeous species of butterflies with different patterns. They all look painted. It's this problem of gratuitous beauty that you find in nature. That I'm a big swimmer. I'm a compulsive swimmer, and we go to Hawaii or any place that has tropical fish. I'm in the water the whole time. The Picasso triggerfish, the humu nuku nuku apu ao. These they look painted, for goodness sakes, and you cannot tell me that there's a differential advantage in survival in one gorgeous pattern versus another. It looks for all the world that they were created because it pleased the designer to do so for our enjoyment and edification. And so I think some of these theists have been too cautious or too defensive, because we've lived in a naturalistic kind of era where people have naturalistic sensibilities. And if you invoke a divine action as a cause for the origin of the universe, with naturalistic sensibilities, people might abide that. They may say, okay, I'm okay with God creating the universe, but I don't want him doing a lot else after that, because that's just, but why not? If what we're really dealing with is an agent who has powers that are analogous to ours, but greater than those, and if he had the power to bring the universe into existence from a true singularity in which there was neither matter or energy or space or time at the beginning, it's not really so hard to think that he might have acted not only at the Cambrian explosion, but also in the mammalian radiation, or at the angiosperm big bloom, or at that extraordinary event you described in the transition from prokaryotes to eukaryotes, because those ways of processing information are completely different. The circular chromosomes in the prokaryotic genome are nothing like the way the eukaryotes process information. And you can't have a series of gradual steps that gets one from one to the other. Those systems need to be re-engineered. So this was the gravamen of the article I wrote with Gunter Beckley, is that there are not just one or two, but there are many discrete explosions or bursts or saltations was the old word in the 19th century of biological innovation. And if we read the fossil record at face value, it lends itself to the suggestion that there may have been more than one act of design. And I'm okay with that. I'm not so, I've had to wean myself off of those same strictly naturalistic sensibilities. But I think a lot of people are coming that way because there's so much in this in the world around us that is, what's the old Shakespeare quote about the more things under heaven and earth than are dreamt about in Horatio's strictly materialistic philosophy, I guess would be the way I'd paraphrase that.
Yeah.
My last question, real quick.
No, go ahead. Great question.
What is the probability? You've just explained how just going from prokaryotic to eukaryotic is a big leap. And in your signature of the cell, you said there's 5 reasons why RNA won't self-organize into so with all these problems, just give me a number, doesn't have to be exact. What are the chances that life could have arisen randomly by chance, the way the evolution said?
Well, I only made a calculation for the origin of a single functional protein of modest length, because if you get into looking at all of the different proteins and interactions between them, the numbers, it becomes an intractable mathematical problem. Although there have been now calculations of the proteanome improbability, and it's okay. And that was a number. I mean, this was I'm pulling the scientists' names. Anyway, the number is one chance in 10 to the 79 millionth power to get all of the interactome. It's called it's not just building the proteins by chance. It's getting the interactions between them properly structured so that you get the correct functional integration of the system.
I got it. So you're saying there is a chance, right?
Yeah, right,
Okay,
right.
no more questions.
But my number in signature was
Dumb and Dumber, Bill.
yeah.
Well, he said there's a chance, right?
Yeah. Well, but hey, let's talk to that rather than give it. My number for a single protein of 150 amino acids in length was, if you take into account sequence specificity, chirality, and the need for exclusively peptide bonding. And then you also take into account every event that could have occurred since the beginning of the universe, where an event is described minimally as an interaction between two elementary particles. It turns out that you get I think 10 to the 139th possible events to explore a sequence space of 10 to the 164th power. So if every event from the beginning of the universe was devoted to searching for an amino acid sequence of 150 amino acids long, you'd still only get to search 1/10 trillion trillionth of the total space, which means it's overwhelmingly more probable that such a search would fail than it would succeed. And that's the problem with the Dumb and Dumber idea of, well, if there's a chance, therefore that's a plausible explanation. No, if it's overwhelmingly more overwhelmingly more probable than a random search will fail than it will succeed, then chance becomes overwhelmingly more probable to be false than true. And we don't like hypotheses like that in science, which is why every origin of life researcher has rejected the chance hypothesis. They're looking at self-organization or RNA world.
So the good news, Bill, is you have a chance. The bad news is you don't have a snowball's chance. So let's go with, I think we have quite a few great questions queued up here. And Brady or Daniel, you want to tell us who's next?
Yes, Cy, you are on board. Unmute yourself and ask your question.
Hi, Steve. It's good to see you. I love your book.
Thank you.
I especially like the opening when you were talking about that debate with Krauss and Dennis, because I was watching that on a live stream in my church. We brought it into our church. We had quite a gathering there, and
oh, I'm so sorry. That was most embarrassing moment. You know,
I can understand that, but I'm happy that at least both of your co-debaters was somewhat sympathetic to you, I think, if I remember correctly. What I want to ask you about is the connection between biological evolution and the origin of life. Darwin never tried to explain the origin of life, and even Dawkins, who I share your feelings about, has said that biological evolution, Darwinian evolution, really has very little to say about the origin of life, which I think is completely true, because the mechanisms of the origin of life require there to already be life. In other words, you have to have not only DNA, which can give mutations, but you also have to have very accurate replication of the cell, right? So my question to you is, philosophically, do you think it's advantageous for theists to make a clear separation between the scientific and theological issues related to the origin of life versus evolution once you have Luca and you go on from there?
Well, I do, in part because I think you can get to theism without questioning Darwinian evolution.
Right.
Because the chapter 10 in my book, in which I question the creative power of the mutation selection and argue that there is evidence of intelligent design, at least in the higher taxonomic categories, as a counter to biological evolution, that's in a sense, that's a bonus chapter in my argument, because I argue for the intelligent design of the universe based on the fine-tuning. I argue for a transcendent intelligence based on the evidence that we have for a definite beginning to space and time as well as matter and energy. In other words, the cosmological singularity, the Big Bang idea. And then I argue for an intelligence who is active in the creation based on the presence of big bursts, or at least one burst of information that's necessary to build the first life. So I don't think you need to question Darwinian evolution in order to challenge a materialistic worldview or an evolutionary explanation for the origin of the first life. That said, I think there's good reasons to question it, and good evidence of design at the higher levels in living systems and not just at the level of the first cell. To amplify your point, though, and I think it's a very good one, it's important for people to understand why the origin of life is anomalous in respect to the evaluation of evolutionary theory. And that is that natural selection really can't play a role until you have self-replication.
Right.
But in all living cells, self-replication depends upon DNA, RNA, and proteins, the origin of which we're trying to explain. To put it more precisely, the information in which we're trying to explain in all origin of life scenarios. So, and origin of life people have recognized this from the beginning. We're really stuck because we can't invoke natural selection to get the process going. Now, Alexander Oparin, who was the pioneer in chemical evolutionary theorists, the great Russian scientist, did propose a theory of prebiotic natural selection in the 1960s, but that was roundly critiqued by leading evolutionary biologists, including Theodosius Dobzhansky, who said prebiotic natural selection is a contradiction in terms. Christian de Duve, a leading origin of life researcher from the 90s, a Nobel laureate, said exactly the same thing. But origin of life people have attempted to circumvent that problem by invoking a selection mechanism that works prior to the development of a full-blown living cell. And that's part of what's going on in the RNA world hypothesis. The idea is that you could have not a cell that's capable of self-replicating, but you could have an RNA molecule that has the information in it that is sufficient to build, to both copy itself and also catalyze certain reactions so that RNA could play the role of both DNA and protein. And if you've read Signature in the Cell, and thank you for those of you who've referred to it already, but it's a clever hypothesis, but it's fraught with difficulties, one of which is that the catalyzing capabilities of RNA are not actually the same as what true enzymes do. And they only catalyze a very small number of relevant reactions in life, and not the full suite you'd need to get a full-blown cellular metabolism going. But beyond that, here's the real kicker from the information standpoint, in the way I make the argument for design based on information. Turns out that we have been able to build in the laboratory RNA molecules that can copy a small portion of themselves, about 10%. But they, to do that, even that limited capacity for self-replication depends on RNA molecules that have very specific arrangements of bases. And those arrangements are always provided in these laboratory experiments by the ribozyme engineers, by the scientists. So what they end up inadvertently modeling is the need for intelligence to infuse information into a molecule to get even primitive and incomplete partial self-replication going. So I don't think the RNA world attempt to get around the need for something like a selection mechanism has worked at all. So I think your point is very well taken, but I have independent reasons for being skeptical of the ability of mutation and natural selection to generate the amount and kinds of information necessary to build whole new, for example, animal body plans. So for me, it's a both and, but you don't need both. You could make a strong theistic case based on Big Bang, fine tuning, and origin of life without getting into biological evolution. You're absolutely right.
Thanks. I love that answer. Thank you.
Yeah, good question, Cy.
All these are good questions. Sorry the answers are so long.
Daniel or Brady, do we have somebody else queued up?
Yes, Ken, and he is on. Ken, you're ready to go, buddy.
All right. Thank you, Dr. Meyer, for gracing us with your presence. As most people here know, I'm a former believer. I was with Wycliffe Bible Translators in Africa, and about 20, year 2000, about 21 years ago, I drifted into deism and then agnosticism and quasi-atheism. I don't think I've ever called myself an atheist. And I have to say that every time I read a book like yours, it pulls me more towards it, from my agnosticism more to the theistic side of agnosticism. And then I read something by Sean Carroll or somebody like him, it pulls me a little bit to the left of the dial. And so I find myself swayed easily sometimes by various arguments. And yours is one of the best, I have to say, that I've come across on the theistic side. And I probably would, if I were to come back to a theistic position, it would probably still be more deistic, because I have so many questions about the Bible and how it all fits together. But that's not my question. My question today is about a portion early on in your book where you argue that a Protestant Christian understanding of a divine lawgiver was a prerequisite for the origin of science, with its assumption of an orderly and consistent universe. It seems to me, though, that it would be impossible to imagine a naturalistic world giving rise to us if nature weren't sufficiently orderly and consistent to begin with. On the other hand, it's entirely possible to imagine a theistic world, perhaps like Martin Luther conceived of, where every comet or storm or disease was some sort of divine intervention that may have been capricious or arbitrary or undetected or unpredictable. It's totally feasible or totally possible to imagine a theistic world in which things happen unpredictably than it is to imagine a naturalistic world in which things happen so unpredictably that it could never give rise to biological evolution or human beings for us to sit here and contemplate the situation. So based on prior probabilities and Bayesian thinking, it seems to me that you could make a case that naturalism fits more comfortably with the idea that naturalism with us in it, that's the key, with us existing in it, is more probable or is more consistent with the idea that the universe has to act consistently than a theistic world would be, if that makes sense.
Yeah, let me. First of all, you're breaking my heart, because I went the other direction, and I love people like you that are struggling with these issues. I was thrilled to get invited to this, because these are the big questions. And I one of my closest colleagues when I was teaching was a Wycliffe Bible translator, spent 50 years translating the Bible. He just finished it for a tribe in northern Nigeria. They had a big party, and so I can imagine the heart-wrenching deliberations that you've been through in your journey on this. So
for sure.
So thank you for the sensitive question and even just sharing a little of your background on that. Your question reminds me, it's not exactly this. One correction, first of all, just as I did not, or hope I didn't, argue that it was Protestant Christianity that gave rise to the notion of a lawgiver. I think there were things happening in the Reformation and in late medieval Catholicism, where both branches of Christianity were rediscovering the Hebrew Bible. And the concept of the laws of nature actually come out of a Christian reading of the Hebrew Bible during that period of time from roughly 1300 to 1700. So all three theological influences are there: Judaism, and both Protestant and Catholic Christianity. There's a really interesting technical article on this in the History of Science by a guy named Edward Zilsel on called The Genesis of the Concept of the Laws of Nature. It's really interesting. It's not a self-evident concept. The Greeks didn't really have it. But your question reminds me a bit of something that's called the weak anthropic principle, which it's a little different. It's about the fine-tuning, not the laws of nature, but it says, look, there's not anything really to explain here in the fine-tuning, because if we didn't live in a finely tuned universe, we wouldn't be here to observe it. And so, of course, we live in a universe that has properties that are consistent with our own existence. I think you could make that same kind of argument about just the laws of nature generally. And a part of that then also it does incorporate the notion that the laws in their fundamental constants are also very finely tuned. There's a problem with that way of reasoning, I think, for the strict naturalist, in that it conflates explanation and explanans, the thing that the thing that needs to be explained and the explanation. And let me just run the critique of the weak anthropic argument by you first, and then see if you think it applies to the puzzle you're posing. It is absolutely true that we must live in a universe. It's logically, necessary that we live in a universe which has properties that are consistent with our own existence. And since fine-tuning is necessary for us to exist, then we must live in a universe that has finely tuned laws of nature and initial conditions. But the question that we're asking is not about explaining our observations. We're asking actually a question about the origin of the fine-tuning itself. We're asking why and what causal process or mechanism or event is responsible for the fine-tuning. And so while it's true that we must live in a universe that has properties that are consistent with our existence, it's not true that it still remains a puzzle as to why the properties that are consistent with our existence are so incredibly exponentially improbable. That's the thing that needs to be explained. That's the thing that surprises us. And in the same way, the consistency of the laws of nature, as well as their fine-tuning, does require an explanation, not an after-the-fact observation that, yes, we must live in a universe that has laws that are orderly or that has laws that are finely tuned that make our existence possible. Yes, I agree with that. But that's somewhat tautological. It's a necessary condition of our observing ourselves and the universe around us, yes. But it doesn't, that observation doesn't explain the origin of those features.
I agree with all you're saying there, and that's not. My point was a little bit more nuanced than that.
Okay,
I understand what you're saying about like the firing squad and everybody, 100 marksmen trained on you, and then you wake up and you and lo and behold they all missed you. So I understand that argument. That has force to it. All I'm trying to say is I'm taking a kind of a more narrow, very narrow, specific challenge to your argument that Christian theism is a prerequisite to scientific inquiry, to our understanding of scientific inquiry, because it seems to me that under theism, one could imagine any number of forms of theism in which the physical world doesn't even exist, for one, or physical things happen just kind of more or less randomly, but God holds it all together at every moment, so that yeah, there's all these random things that would make scientific inquiry impossible, and yet theism would still be valid, right? But we don't live in that world. We live in a world in which could only be possible. In other words, there's no other way in which naturalism could be possible. It's its only incarnation that's possible. Where there's many incarnations of theism that could. Where God could be intervening at any moment and doing his bidding, such that scientific inquiry would be impossible.
Okay, there's another analog in the reasoning here that may help. First of all, I wouldn't argue, I was arguing as a matter of historical fact that theism and a particular mix of Judeo-Christian theistic ideas gave rise to modern science, and that there were explanatory resources within that Judeo-Christian worldview and concepts that were alien to the Greeks, that were alien to pagan societies, that were alien to a lot of other worldviews that made science possible. Now, the concept of the laws of nature, might you get that some other way? I don't know, but here's if you remember in chapter 12 of my book, I was talking about the cosmological argument. And I was addressing something that has a similar logical structure. I can't say as a theist that I would necessarily go to the mat for the idea that God must have created a world that had a finite beginning in time. You could, as a theist, think of God constantly creating and having done so from eternity past. So that God is in some way the ground of all being, but yet there's an eternally existing universe. So in mapping out what I would have a right to expect as a theist, I couldn't say I would have 100% right to expect a finite beginning, but I have a comparatively higher right to expect a finite beginning on theism than I do on naturalism, which wants to say that the matter and energy are eternal and self-existent. And so the comparative Bayesian probabilities are very different with respect to that data point. And I would say in the same way, you might think of God creating a chaotic world, but you have a much higher right to expect an orderly world coming from an agent who is benevolent and omnipotent and who has revealed himself in scripture, for example, if you want to even bring in explanatory resources from the Judeo-Christian tradition as a God of order, than you do if you're positing a polytheistic concept of many gods, or a pantheistic concept where God is not a mind and where physical reality is an illusion, or even a naturalistic worldview, which has a difficult time explaining what a law of nature is. And so that's more the way I would make that argument. It's a matter of, it's not saying absolutely we know God would make only one and one kind of argument, so there's only one version of theism, or only one possible relationship between God and the natural world, but rather I'd argue that that we have greater reason to expect an orderly universe or a fine-tuned universe on theism than we do on competing worldviews. And I use some examples like in chapter 12 of a hiker going into a little cabin. As he's walking into the cabin, it looks disheveled and run down, and he thinks, okay, I'm assuming he adopts the broken down cabin hypothesis. Now, but once he gets inside, he realizes the cabin, oh, there's a steeping pot of tea on the stove, there's a shower running in the back room, there are dirty dishes. Now, on the inhabited cabin hypothesis, he couldn't say for sure that he would find all those things, but having found them, it makes the inhabited cabin hypothesis more probable than the abandoned cabin hypothesis. And I think it's that kind of reasoning that confers greater explanatory power on theism with respect to some of these things we're talking about.
Yeah, I mean, I'd like to have a longer conversation, but obviously there's more people have questions. But so I'll pass on to the
Ken, are you?
Thank you for being here.
Yeah, no problem. They're great questions. Are you based in Dallas, like a number of the people on the call?
Yes.
We're going to do a science faith conference there next year in January. You have my permission to corner me, and let's continue the conversation. I'd love to see you.
All right.
Okay. Yeah. Good.
Right.
Hey,
Thanks.
Ken, great questions as always. Thanks. Yeah, Brady, do we have somebody else?
Yeah,
up?
Susan,
Yeah.
if you would go ahead and unmute and ask your question.
Oh, okay. I thought you would ask. Which one? Well, I do
Whichever
have
one
a
you
question.
want.
Okay, one that I asked that I don't have to read is, well, wouldn't it take a long time for the Earth to be terraformed? Therefore the millions and millions of years. I didn't see you address that.
Oh, sorry to interrupt. Go ahead.
No, that's okay. Go ahead.
Yeah, no, it's something I might well have said in response to Bill Cluck's question. There are anthropic considerations in the length of time from the Big Bang to the origin of life on planet Earth. It turns out there are physical reasons that that require the great ages in order for life to exist. So some of those have to do with the fine-tuning of the planetary system. Some have to do with the structure of galaxies, but there are anthropic considerations that that necessitate great ages, and therefore, in addition to my appeal to divine extravagance, you might also say there were design reasons for taking a long time to allow the universe to evolve and unfold in the way it did, making the Earth and our galaxy a fit habitat for life. So that's a very good point.
By the way, Hugh Ross says that reason God took so long is for the oil to develop from, the compression of the coal and so forth, which would take millions of years. So we can drive big trucks in Texas, I think was his.
Okay. I work in the oil industry, so I can go with that. Whatever.
We do know God loves Texas. This confirms that. So who else do we have queued up, Brady?
All right, Tina, you are next. Thank you for waiting.
Hi, thank you. So just a brief background on me. I am a Christian, but I do have multiple atheists and or agnostics in my life. Several of them are close relatives. So my question is, how do you respond to someone saying that the argument that arguing from the fine-tuning of the universe is unreliable because you cannot calculate the odds because you don't know the process? You're making all kinds of assumptions about it. Since we don't know how the universe came about, you can't make calculations about probabilities. If we knew what the process was, we would say, oh, okay, well, the odds are actually quite high because all of these things are just part of physics and they're just going to eventually happen. So, we know less than 1% of the universe's knowledge that's out there. So how can we possibly make claims about fine tuning?
Very good question. This objection to the fine tuning argument has been articulated by a German physicist named Sabine Hoffenfeld. I'll just not pronounce her last name very well. And I've written a critique of her critique with our physics colleague here at Discovery Institute, Brian Miller. One of the things that's important to realize about the fine tuning is that the fine tuning affects the most fundamental processes of physics there are, and therefore does not lend itself to explanation by reference to deeper processes. We're talking about the constants that are part of the structure of each of the four basic fundamental forces of physics: the weak and strong nuclear force, the electromagnetic force, and the and gravitational force. So appealing to some other process when those are the most fundamental processes in physics is itself a bit question begging. Now, some people have said, well, maybe we're going to come up with one grand unifying theory that will show that all four of the fundamental processes of physics can be reduced to one great law of physics or one great force. Of course, Steven Weinberg was able to unify the weak nuclear force with the electromagnetic force. We now talk about the electromagnetic weak force. But if you just do a little thought experiment on that, you can see that that's not going to solve the problem either, because in all of our explanations of particular events that take place in the universe or in our own experience, we do not refer primarily to the basic laws of physics to explain. Rather, we refer back to causal events or conditions. And let me give you an example that I used in my PhD thesis when I was brash enough to actually critique Stephen Hawking, which was probably stupid to do in Cambridge, but I did it anyway. Hawking was hawking this idea of one grand unified field or force that would explain everything. And I argued that even if we had such a force, we wouldn't be able to explain any particular events. Let's take the law of gravity. The law of gravity is consistent with an astronaut flying to the moon and an apple falling to the earth. What explains the difference between those two sets of events? Well, it's not the law of gravity. The law of gravity is so general that it applies to all movements and all interactions between bits of matter on Earth. The difference that makes a difference between those two conditions, one going up and one going down, is not the law of gravity. It's the way in which we have harnessed the material of our world to structure a rocket ship as opposed to simply picking an apple. So the antecedent conditions are what account for the difference. And the antecedent conditions relate to differences in the configuration of matter, okay? Not the basic laws or processes of physics, which are too general to actually help us explain particular events. And so even if we had one grand unified theory that reduced all the forces to one force, such a theory would be so general as to be of no help in explaining the particularities, the unique features of our universe, because that law would apply to everything, okay? So to get explanatory power out of physics, we need to couple laws with initial conditions and what are called boundary conditions or boundary constraints, how we configured matter. And so the fine tuning is not going to be ultimately, the fine tuning pertains to, for example, the initial arrangement of matter and energy at the beginning of the universe, what's called the initial entropy of the universe. That's not going to be explained by any underlying physical process. It precedes there being physical processes. And similarly, the initial constants of physics, which are essentially a way of describing all the other features of the universe not captured by the variables in a physical equation. There are things that can only be determined by measurement. We're not, even if we got one grand unified theory, we would still need something like a big constant, which is capturing the particularities in order to do any explanation. So we're not going to eliminate the need for underlying process, or we're not going to explain away the so-called free parameters in physics by one grand physical process. And one last point about this, which was the point I made in response to Sabine's article. And that is that if there was such a process that said, and her example was, well, let's look at, say, all the range of possible gravitational force constants. And there's a sort of natural range that physicists look at. Her idea was, well, maybe there's an underlying physical process that biases the outcome so that we get a constant that falls within a very narrow range. But here's the rub. If you have a process that biases things towards one narrow range out of a much larger range, that process itself is going to need to be finely tuned. It's got to say it's biased is to say it's directed towards an outcome out of a range of possible outcomes, which is just another way of talking about fine tuning, and you're right back to where you started. So I think there's multiple problems with this idea that we can refer to some general law or some process, even in principle, and explain away the particularities of the fine tuning or the universe in which we find ourselves.
Thank you very much.
Yeah, did that answer your question, Tina?
I'm going to chew on that for a while.
Okay.
I have a friend in here who knows a lot more about this that I think he'll help me to be able to process everything.
And this will be some very intelligent conversations with your agnostic friends. I do unpack this argument a bit in, I think, chapter 13 of the book. What I just
of this one?
Yeah, that one. Yeah.
Okay. I've read some of the book, but it's so heavy that I haven't been able to get through it all.
I'm sorry. It does go into. My kids say, "You do go on, Dad." So sorry.
Before we go to the next question, I had a kind of a quick question for you. What would you say to someone who would argue, when you're talking about maybe the Kalam argument and everything that begins to exist has a cause, the universe began to exist, and they would say, well, if matter, energy, space, and time, and specifically time, came into existence, then that really throws causality out the window, because you're assuming that there was a before and after. And without time, you don't have a before. So we don't know what happened before the singularity. And in fact, even saying before the singularity is begging the question, because we don't have time yet. So how would you address that objection?
Well, I think in the first place, the alternative to that is saying that the universe came into existence for no reason at all without a cause, which I think is essentially contrary to basic principles of reasoning. And it'd be like saying that a Bengal tiger could pop into existence from nothing, or A football stadium could suddenly come into existence. But I don't unpack the cosmological argument in that strictly deductive form. I am interested in causality, and I think all explanation requires causality. And so I unpack it as an inference to the best explanation, where the most causally adequate explanation would have to be something that transcends those domains of matter, space, time, and energy. And I don't think it's incoherent to think about time having a beginning or being brought into existence by an agent or entity that exists outside of time. So I think that theism has unique explanatory resources in that it does posit the existence of an entity that does transcend or exists independently or separate from time, matter, space, time, and energy. And therefore, there is a coherent explanation for the origin of the universe on theism. I don't think on basic naturalism you can get such an explanation because by nature we mean matter, space, time, and energy, before which there was no matter, as I've said, to do the causing. Now, the alternative that's proposed to explain the origin of the universe by reference to the origin of the universe by which we mean matter, space, time, and energy is the quantum cosmological approach. And that posits something independent of the universe as well. So it does attempt to explain the origin of the universe, but it posits a mathematical structure that's based on, that has an analog to quantum mechanics. But the weird thing about that is it posits something which has no physical reality, only mental or conceptual reality, which is to say a set of mathematical equations, the Wheeler-Dewitt equation, which when solved produces something called the universal wave function. And so you have this weird kind of, the alternative explanation is to say physics has produced, or physical equations, pure math, a realm of pure math with no matter, space, time, or energy, in some way explains or produces the universe from a state of nothing physical. I think that's a very interesting proposition, because what we know from experience about physics, or about math, is that it's conceptual, and it only exists within a mind. And so as Alexander Velinsky, one of the great quantum cosmologists, has himself, in a sense, tumbled to, at the very end of his book, Many Universes in One, he says, what tablet could these quantum physical laws have been written on before there was any matter, space, time, and energy? In our experience, he says, math always exists in a mind, so are we therefore saying that the universe came out of a mind? I think there are three basic options. You could say the universe has no explanation, and or you could say it has a materialistic explanation, which I think clearly fails, or I think you could say it has an explanation by reference to a transcendent mind who exists independently of space and time. And I think that is the explanation that has the most consonance with our own experience and has the best causal adequacy.
Thanks, Stephen. Brady, who do we have lined up next?
All right, our next one is Richard. You're up, Richard.
Hey, good evening. I'm Richard. I'm an atheist, but I do have your book. I did buy your book and read it. I just wanted to say, I heard one of your lectures once where you said you had, I think it was a lecture about theistic evolution, and you said you had identified like 17 gaps. I might have that number wrong, but like 17 gaps that you said required more explanation. There wasn't enough evidence there to say that one phase led to the other phase. So, I mean, this was across the cosmological timeline, from formation of planets to life, to different species, to consciousness, to discoverability of reason. And I forget how many of those, and I don't mean the word gaps like God of the gaps, but 17 spaces that you said would need more data before you would agree that these things just happened without some sort of a powerful mind intervening. And I'm wondering if each of those spaces are equal to you, or if like origin of life is even more amazing than different species, or do you have like a priority among those spaces? And did I get the number right? Or are there different? Is there a different number than what I just?
Fantastic question. I love your the flexibility of your mind too, that you can put yourself in a theistic framework for asking a question like that, even though you're an atheist. I have to do that all the time, you know, so that I love this club. You guys are, your way of discoursing is very refreshing. The article you refer to is a piece I wrote with the paleontologist Gunter Beckley, whom I mentioned earlier in the podcast tonight. We wrote an article, and I forget the title. It's in a big book we wrote, Critiquing Theistic Evolution.
Right.
And the number is correct. It's 17 major saltational events in the history of life: abrupt appearances, explosions. There are different names for them in paleontology. Punctuations, where you have a major innovation in form, where you have significant anatomical or body plan level change that arises abruptly, often well beyond what would be expected given evolutionary waiting times. And so these were purely biological, and they start with the origin of life. Okay. There are other events in the history of the cosmos, the fine-tuning of the universe, which I think most of which was set very at the beginning or very soon after, or some of the planetary fine-tuning, which may have come later and might justify an inference to a discrete action of an agent. But we were just looking at living systems. So we had the origin of life, the origin of the eukaryotes. We had the Ediacaran explosion, the Cambrian explosion, the Great Ordovician biodiversification event, and then other things like the first turtles, the first fishes, the first birds, the first mammals. The mammalian radiation is an amazing event in paleontology. There's 15 to 17 new orders of mammals that come into the fossil record, each very discreetly, often with anatomical structures and features that are completely anomalous, that never existed before, like the echolocation system of bats, or with turtles. You know, they in the Triassic, they come into the record. They've got these 50 bony scutes and these unique bone structures that don't exist in any other reptilian-like organisms. So we just, and then the angiosperm big bloom was one of them. So they're the marine Mesozoic revolution with the plesiosaurs and the sea reptiles. So there are a bunch of these big saltations, big abrupt introductions of new form into the fossil record in ways that defy Darwinian gradualism, and I think which do raise big design questions. How do you build that much structure that quickly, given the amount of time you would need for the coordinated mutations, et cetera, the waiting times problem?
Can I interject with a very quick question about, let's say you have a turtle that did not exist before yesterday, and today you have a turtle that exists. If I had a video camera there to go back those millions of years, would I see a live birth somewhere, or would I see something pop into existence out of nothing? Or would it be some sort of would there be a birth event that God kind of intervened and caused a radical change, but it was still a succession? Or what does it look like in your view?
I don't think we know. And I would just come back to an earlier point I made about our sensibilities being very much shaped by the last 150 years of intellectual history, where materialism has really been the dominant thought form. In previous eras, people did not have a problem thinking that God may have acted more than once, or that he may have acted discreetly. One of the big appeals of theistic evolution is not that it fits with the evidence we have, because we have all this evidence of very discrete infusions of biological form and information at definable points in time. And in the Cambrian period, for example, there's a big Cambrian find in China with the fossils there. And there's a paleontologist that I've spoken to who gave a nice endorsement for my first book. He said, these form, when we're talking about 10 million or 5 million years or whatever it is, there's between 13 and 16 different animal body plans representing that number of phyla that come into the Cambrian fossil record in China within about a 5 million year window. That in practice is, a few feet of rock. It's like you go through columns and columns and columns and columns of rock or sedimentary layers, and then boom, all of a sudden you've got all these forms of life that didn't exist before. I mean, it's very dramatic, okay? Now, did they evolve gradually from the Ediacaran or whatever was before, and all the intermediates just were not preserved? There's a whole bunch of reasons to think that's implausible. But my thought is, you've got a discrete infusion of form that requires a equally discrete infusion of information. The creation of information is habitually associated with conscious activity, as one of the great information theorists has said. I don't know. Would we have seen it just go? Would we have seen a poof event? Maybe so. If there is an omnipotent deity, and I think there are good reasons to believe such a being exists, I don't have a problem with that, other than the problem of imagining what it would have looked like. We do very discrete things in our experience. I used to, when I was teaching, arguing about the question of free will versus determinism, I would shock students by dropping chairs or throwing erasers, or to illustrate the idea that agents have the power to initiate new lines of causation discretely at times and places of their choosing. If we have that power, a divine agent, indeed one that is responsible for the origin of the universe from nothing physical, might have been able to create turtles without antecedents. On the other hand, maybe they evolved by gradual processes. I just don't see any evidence of that for organisms that represent these higher taxonomic categories.
Well, we can always count on Ken to ask a great question like that. Appreciate that, Ken. I think we have do we have a question next from Daniel? Daniel?
Yes.
Yeah.
Thanks for coming on again, Steve. It's great to have you again and talk to you.
I'm trying to find your thumbnil on the screen. It's like little baseball cards. Sorry.
It is. A little pun that leads me into my question. There's a physicists on a cruise ship, a cruise of physicists on a ship. And the ship captain comes on and says, ladies and gentlemen, this is your captain speaking. Unfortunately, the surfing pool is broken. Apparently, one of you looked at it and collapsed the wave function.
Oh, my.
So sorry about that.
Physics jokes, yeah.
Physics jokes, yes.
They go over like lead balloons, yeah.
But anyway, that I did want to have you touch on the many worlds and Hugh Everett in the latter chapters of page 390 or something. That I forgot what chapter it is. But the many worlds, Hugh Everett, because that's what Dr. Sean Carroll is advocating in his last book, The Big Picture, going with the many worlds thing. This idea of a wave function being the cause of the universe has an intrinsic front load information problem, doesn't it? Can you explain what the many worlds is and why it doesn't work for refuting the intelligent design hypothesis?
Yeah, well, this comes up first in the area known as quantum cosmology. And I'm going to just take a breath and slow down to make sure I explain this. Don't get going too fast. If people remember some basic, it's the physics of the very small is the physics of the very weird. And the physicists of the 20th century discovered that electrons, subatomic particles, photons act both as waves and as particles, depending on how we choose to observe them. That's weird because waves are spatially extended, particles are spatially discrete. But there's a whole mathematics that was developed to describe the way in which these photons or electrons or other subatomic particles work and how, and to capture this wave particle duality, as it's called. And that mathematics is called quantum mechanics. And it's very useful, helpful mathematics, and it does allow us to make predictions and good accurate descriptions about things that are going on in this subatomic realm. Now, one of the strange things that's happened in modern cosmology is that the cosmologists have appropriated the mathematics of the quantum world to try to help them explain the origin of the universe itself. And whereas something called there's something in ordinary quantum mechanics that has the symbol psi, it's called the universal, or called a wave function. And what the wave function does is that it allows physicists to calculate the probabilities associated with finding a particle at any place along a kind of spreading waveform where it might be, but at which it won't be found in any particular location until an observation is made. And that's what's referred to as the collapse of the wave function. So psi represents this range of possibilities and allows physicists to calculate the probabilities associated with those possibilities. Okay, that's like a little review of basic quantum mechanics. It gets really hard, I know, and weird. What the quantum physicists have done, or the quantum cosmologists, the cosmologists trying to explain the origin of the universe from literally nothing physical. This was the gravamen of the import of Lawrence Krauss's book, who was popularizing one of the two great quantum cosmological models, in this case formulated by Alexander Vilenkin. The other one was formulated by Stephen Hawking and James Hartle. And anyway, the quantum cosmologists say, hey, maybe we could explain the origin of the universe as a consequence of this same kind of quantum physics. And instead of having a universal wave function psi that represents all the possible locations, positions, or momenta that could be associated with subatomic particles, why don't we develop a universal wave function that describes all the different possible universes that could emerge out of that void, out of the nothingness, where each possible universe is conceived of as a different, as having a different spatial geometry and configuration of matter, or a different matter field and spatial geometry. So it would be a different universe with in brief, a different gravitational field. And there could be lots of different universes with lots of different gravitational fields. And if our psi function, our mathematical solution, includes a universe that, like ours, that has a reasonable probability of being observed or coming into existence, we're going to say we've explained the origin of our universe. If our universe is one of the universes described by a psi function, a universal wave function, will have explained the origin of the universe itself. But there's a catch. First of all, the psi function is pure mathematics. It's not a physical thing. Mm-hmm. And math can't cause physical things to do anything. Math alone, math only helps us cause things to do things if we're using math to guide our calculations or our designs or engineering. Math exists in mind. So this very research project of quantum cosmology seems to presuppose a prior existing mind. And Vilenkin himself, whom Krauss popularizes, points that out at the end of his book, Many Universes in One. Krauss doesn't mention that in his popularization. Mm. Secondly, however, the universal wave function, like an ordinary wave function in ordinary quantum mechanics, is a solution to a prior equation, a big, hairy equation. In ordinary quantum mechanics, it's the solution to something called the Schrödinger equation. Yeah. The analog to the Schrödinger equation in the cosmological case is something called the Wheeler-Dewitt equation. Yeah. And this is an equation developed by brilliant physicists, John Wheeler and DeWitt, whose first name I'm suddenly forgetting. And what they were trying to do was to depict, they were trying to model the origin of the universe, and in the process, synthesize our best ideas about quantum mechanics with our best ideas about gravity. Because quantum mechanics and Einstein's idea of general relativity, his theory of gravity, don't quite mesh for a bunch of reasons. So this was an attempt to bring those two theoretical sets of formulae and two theoretical apparatuses into a synthesis. And that's interesting because this equation is it's a functional differential equation. It is in some ways analogous to the Schrodinger. So, but there's a problem here. So basically the idea was we got this equation that captures our two greatest theories of physics and synthesizes them somehow. And if we could solve it, then we'd have a wave function that would allow us to possibly explain how the universe came out of nothing physical. Wow, that's a tall order, but that's the research program. Yeah. Here's the interesting thing. In addition to invoking all this pre-existing math that has no physical instantiation in a matter, space, energy world, you can't get a universal wave function, the thing that would do the explaining, unless you solve this prior equation, the Wheeler-Dewitt equation, and that equation cannot be solved unless you impose restrictive boundary conditions on it. And a boundary condition is just something in math that limits degrees of mathematical freedom. It says this way, not that way, 0, not a 1, X, not a Y, okay? But what are you doing when you're restricting degrees of mathematical freedom?
You're choosing.
You're choosing. You're imparting information into, in this case, into a mathematical apparatus in order to get a desired outcome, a universal wave function I that includes a universe like ours.
So this is like, Steve, this is like what you said earlier about the biological systems for testing RNA synthesis, that you've got the front end intelligence creating the parameters or being limited by the parameters, if you will, but there is
limiting the parameters. Exactly.
Limiting the parameters, right,
yeah.
right.
So it's a teleological end-directed process that's being modeled. In other words, to get a universe like ours, you got to have an input of information. And the information, where does it come from in all the modeling? The minds of the theoretical physicists.
Right. Bryce was DeWitt's name. Bryce, I think his name was
Bryce DeWitt. Thank you.
Bryce,
Bryce DeWitt and John Wheeler. Yeah, I mean, genius guys, for sure. But this whole program, in other words, presupposes mind at several different levels. Okay. Now, as far as go ahead. That's enough for now. I mean, there's more to be said.
No, that's good.
Yeah,
I thank you.
We're running out of time. We got about 14 minutes left, and we have one more person who's on the queue who hasn't been able to ask a question yet, and that's Phil. So Phil, if you want to get ready, but I know Sean had asked this question in the chat, and I thought you could answer this quickly for us. What resources would you recommend for children?
I did not for children, but for juniors and seniors in high school, and early in college, well, all through college, late high school and college students. I did a 10-part lecture series called True You, Does God Exist? I did a sequel to that, actually, called Is the Bible Reliable? Looking at archaeological and historical documentary evidence for the reliability of the Bible. And I started that second series by addressing the question of the possibility of miracles. Because one of the big reasons for skepticism about the biblical narratives is the default doubt we have about the existence of God, and therefore the resulting doubt about the possibility of miracles, because miracles are, after all, acts of God, and if there is no God to act, then miracles are impossible, and then biblical narratives would be inherently improbable. The probability of a miracle, given scientific materialism, is zero. The prior probability is zero. But if God exists, then it becomes possible to evaluate biblical narratives with a more open mind, because the probability is now non-zero. We might not be able to specify what it is, but it's not non-zero, because miracles are essentially instances of divine action, and that's what is recorded. So I did a 2-part series for younger people who are facing the intellectual challenges that they will inevitably face in college from a predominantly naturalistic professor.
Thank you. And we could find that at like True You?
It's online. Yeah.
Just online.
Amazon has it.
Gotcha.
I did it with Tyndall Publishers, Coldwater Media, Focus on the Family, had a role in it. but it was a course I used to teach when I was a college professor called Reasons for Faith. And
Awesome.
But the first 10 lectures are a high school, late high school level treatment of the subjects in the new book that does not exist. Yeah.
Well, thank you so much, Art. Oh, I'm sorry, James.
Yeah, I was going to say, this is the Atheist and Christian Book Club. Our guest author today is Stephen Meyer, and we're looking at his new book, his new book right now. And we've had a number of questions so far from a variety of different people. If you do have questions, we have time for a few more after we hear from Phil. Do we have any lined up already?
Yeah, we have one. We have at least one more after Phil,
Okay.
if time allows.
Well, let's go ahead and take Phil's question. Phil Bear, you have a question for Stephen?
Yeah, hi, Stephen. Enjoyed the book. I'm not quite through it yet, but I enjoying it so far. I would like to get your comments on just two quick ideas, and I'll try to make this brief. The first one is that I have argued that that naturalism is self-defeating and is logically incoherent for the simple reason that you cannot explain the origin of natural law on the basis of natural law. In other words, natural law cannot be its own cause. It can't be its own origin. Nothing can create itself. And so natural law would have to exist prior to natural law in order for it to cause the existence of natural law. And then the other quick idea that I wanted to just run by you is that last time we had Lawrence Krauss on, and we were talking about the incoherence or the putative incoherence of there being a cause to the beginning of time, that it's incoherent to talk about anything prior to the beginning of time, because if there's no time, then you can't have a prior. And my response to that, I was trying to squeeze in some time to try to flesh that out with Lawrence a little bit, but we ran out of time. But that was that the causality, I think it's incoherent to say that causality has to be constrained by time. The causality can have an ontological reality to it that doesn't necessarily depend on whether time exists or doesn't exist. So I wanted to see kind of what you might have to say about those two things.
Yeah. The second, sorry. First of all, you got the award for looking most comfortable of anyone in the book club. You're reclined in a very philosophical way. I like that. Wait a minute. Sorry. Remind me the first question again. I was thinking about the second.
The first question. The first question was what are your comments on the idea that naturalism is self-defeating?
Oh, right, and Well, here, I mean, it's a very deep question in the history and philosophy of science and the history of physics. What exactly is a law of nature? Okay, and this came up this surfaced with a vengeance in the debate about universal gravitation between Newton and Leibniz in the early part of the 18th century. Leibniz didn't like Newton's idea of universal gravitation because Newton did not specify what was causing the action at a distance. So you got the moon is exerting an influence on the water, the surface of the water on the earth. We call that the tides. But the moon isn't pushing the earth. And the earth is also exerting a force on the moon, but the earth is not touching the moon. So how is that force transmitted through a distance? And Newton came back and said, well, hypothesis non fingo, I don't know. I don't know what causes that, but I can describe it. And that description we call the law of gravitation. He can describe it precisely and with mathematical rigor. And I remember a conversation with my Cambridge supervisor about this. And he was what's called a sociologist of knowledge, a radical relativist about, for example, the existence of laws of nature. He took a kind of postmodern and post-Humean view. You may remember that the philosopher David Hume said that the laws of nature were nothing more than habits of the mind. They didn't have what philosophers call ontological status. They're not things out there. They're just our descriptions of what always happens. We know not why. And therefore, they have no more reality in nature than do the longitude and latitude lines on a map, which are just helping us organize our understanding of geography. They're not actually causing the Himalayan mountains to rise or the continents to be where they are.
Well, if I could just interject something real quick, I think one of the ways to cope with that that awkwardness could be that we could say, rather than say the laws of nature cannot explain the origin of the laws of nature, we could say the forces of nature cannot explain the existence of the forces of nature.
Right. I mean, when you
So
get it
that way we focus on the ontological reality of the forces of nature instead of, and that way we don't get bogged down with, semantics about laws and, what are they?
And to be clear, many physicists get bogged down with this sort of semantic problem. It's a nominalism, where we get so used to talking about the laws of nature, we talk about them as if they're things or if they cause things to happen. But the fundamental laws of nature, the four fundamental forces of nature, have a predictability to them that we can describe with what we call a law of nature. But our description is not causing the force interactions.
Right.
And we don't really know what causes those things. We now have moved from Newton's idea of gravitational force being transmitted through a distance, this occult property, as Leibniz called it, to Einstein's idea of space-time being curved by massive bodies, but space-time is empty. So how is it that a mass actually curves the fabric of space-time such as to create a preferred line of trajectory of motion around it, but still without any pushing and pulling? Space is empty. And then, okay, well, we got rid of that, sort of. It's still with us, general relativity, but string theory posits gravitons. And I thought, oh, finally, we've got a mechanistic explanation for gravity. The gravitons are pushing things along. No, the gravitons are particle-like things, but they're pullers, not pushers. They have attractive properties. And again, no pushing, no pulling in the sense of physical contact. So these fundamental laws of physics are tremendously mysterious. And Newton, of course, had a profoundly theistic worldview, and in the general scholium to the Principia, he paraphrased the passage from from the letter to the Colossians, Paul's letter to the Colossians in chapter 1, saying, "In him all things are moved and held together." And so he ultimately thought what we call the laws of nature are modes of divine action, where God is constantly holding the universe together by his power in an orderly way. When I was having this tutorial about this in Cambridge, my supervisor, who was a radical sociologist of knowledge, who did not believe there were such things as laws of nature, these were socially constructed concepts. And he said, your idea of, and we were discussing Newton in this whole debate with Leibniz, and he said, and I don't know how, but I had not been really advertising this, but he knew I was a theist and a Christian. And he said, your notion of the laws of nature makes sense. And my idea about the laws of nature makes sense. But he said, the one idea about the laws of nature that makes no sense is the view that's held by the majority of members of this department and the physics department down the street, which is that the laws of nature are things that cause things to happen. He said, no, that makes no sense. We don't see the laws of nature. We see physical phenomena that has a regularity to it, which we describe with our math. And so the idea that they have ontological status apart from a motive force that is behind them all, that can act universally throughout space and time consistently, in other words, a motive force that has godlike powers, he says that makes no sense. So I think there is an argument to be developed there, a theistic argument, or maybe an argument to the effect that theism provides the best explanation of the laws of nature if you want to regard them as having some reality. For any kind of realistic construction of physics, I think you need theism. That was question one. Question two, I'm going to have to think about this, this temporal thing. I agree with you. I think the basic notion of causality is not inherently temporal. I think it has to do with one thing producing another. And insofar as even our basic physics is now telling us that time has not always been here, that suggests the possibility of realities that are atemporal. And I think, therefore, an atemporal an entity that resides beyond space and time, that transcends space, time, matter, and energy, and has causal powers in the sense of being able to produce something that did not exist without it, irrespective of considerations of temporality, I think best explains the evidence. In other words, I think a God beyond matter, space, time, and energy has can provide an explanation for the origin of the universe at a discrete finite time ago, before which there was no time, because I do not think the core notion of causality involves temporality, but rather production of something that did not exist apart from that entity. So
that was the correct answer.
Yeah, that's the way I think of it. But if an atheist wants to say, I'm just going to say, well, the universe happened for no reason at all, as Bill Craig has sometimes said, well, then that's fine. They're entitled to that point of view. But that's equivalent to also saying that Bengal tigers or freight trains or baseball stadiums can also pop into existence for no reason at all. And I interviewed him one time, and he said, if that's their point of view, then let the atheists who say that the Christians or the theists are irrational forever be silenced, because the basic principle of causality underlies all reasoning. And I think also the principle of sufficient reason, which is closely related to the principle of causality, but not the same thing, and which definitely does not require temporality to have force, also can underwrite a cosmological argument. So I think there's more than one way to skin that cat that circumvents that objection, that causality is only coherent within a time domain in which you have before and after.
Hey, Brady, do we have time for one more question, as long as it's like true false?
Well, the only other person I had left,
he's not giving you those sorts of answers. Sorry.
The only other person that I had on the queue was Susan had another question. I don't know if it's a quick one or not, but I want to.
It'll be quick.
Alrighty.
Hi, Stephen. I'm over here.
Hello. Oh, I see you on the left-hand side of my screen. Thank you for waving.
Okay. Hi. This is something I don't hear talked about a lot. It's concerning homologies in a way, and also the similarities in DNA. And something I don't hear talked about is an apologetic. Why did God make animals so similar to each other? You talked about structures. Homologies was the one thing, without thinking about it, I didn't grow up religious. Oh yeah, of course. Homologies convinced me when I was in high school that evolution was true.
Common descent, common structure.
Right, but then later, they became Christian Science. Then when I went back to think for myself, the evidence doesn't convince me. I don't see the.
Yeah,
I needed transitions.
There's a really nice treatment of this issue in Darwin's Doubt, my second book, in number. I shouldn't say it's nice. It addresses it head on, and in a book we did jointly called Explore Evolution, we have an extensive discussion of this as well. Common similarity of structure.
No, but I had a particular thing.
Okay, go ahead.
Apologetic for. I've read all your stuff. I'm your biggest fan. Even your essays in theistic evolution.
Oh, thank you. Well, you're on the other side of the discussion. I'll say, God bless you.
Oh, yeah, and God bless atheists too.
Yeah, well, the force be with them. We'll just keep.
I don't hear people say if every single species of animal was so different, or humans were so different from every other animal, then we wouldn't be able to test why we actually know we can't go to Mars, because they tested mice who have a digestive tract like ours. Cosmic rays would make us deathly ill, and we'd be dead by the time we reach there in 6 months. I mean, there are things we can learn in science because we have animals that have an eye like ours, or bones. You know what I mean? I mean, God's goodness. Even in the DNA, similarities. If if things are just so different, we really wouldn't be able to test things like we do and learn more about ourselves through studying the animal kingdom. Hey, do you hear that? I don't hear that.
That's a very interesting point. It's a kind of anthropic consideration that there's a benefit to us and that there are these similarities. But I think there's also something that's really important to be said here about this whole argument from homology. Similar structure can be explained by common ancestry, or it can be explained by common design, that a designer had a functional reason for reusing modular elements that we find in one organism in another. Now, how would you decide between those two kinds of hypotheses? Well, it turns out there are ways of testing that. And one of the things that allows us to decide whether common descent or common design is a better explanation is whether or not the trees of life that are generated by analyzing similar molecules, similar genes and the similarities of their sequences, or similar anatomical characters in the same groups of animals, produce similar trees, or whether they produce dramatically conflicting trees. Because there can only, on a Darwinian account of things, there can only be one tree. There's only one true history of life. And if you choose one molecule, one protein like hemoglobin, for example, and another, and then generate a family tree from all the organisms that have that, and then you choose another protein like, say, cytochrome C, and then you generate a tree of life from that, and then you look at anatomical similarities and you generate trees from that, they should all align reasonably closely.
But we're getting things from all over.
But instead, what we have is a whole bunch of conflicting trees. And I write about this in chapter 6. And the conflicting trees are especially evident at the higher taxonomic categories, where I, again, am most skeptical about common descent. Okay, so on the other hand, a designer can mix and match modular elements to generate lots of, we do this all the time. And the computer people who have been analyzing, we have a lot of software people who are pro-intelligent design. And, you know, one of them said at a conference in London we did in 2016, he said, I'm so unimpressed with this argument, well, that because the chimp and human DNA is 99% similar, therefore they had a common ancestor. Well, first of all, that number is dropping, okay? But secondly, he pointed out that programmers have a vast a store of common source code that they reuse in very different functional applications. And so high degrees of similarity in code is not evidence of, it's not dispositive of common ancestry. It's also something that we intelligent designers do. And mosaic organisms that have modular elements that are uniquely arranged, but where the elements have similarity to elements in other organisms, I think are actually evidence of design. So the conflicting tree problem is something to keep your eye on. I think it says this isn't a signal of common descent. It's a symbol of common design.
Thank you very much.
It was very, very good. And I've had a fantastic time. I think I speak for everybody here. This was excellent, Stephen. I did want you to take just a second as we close out. You have a great website for the Return of the God Hypothesis, kind of goes with the book, has some interviews and things. Could you tell us where we could find that website?
Yes, thank you for asking. I have some great help producing that. My assistant, Andrew McDermott, and our web designer, Nate Jacobson, and now my son, who's been helping us over the summer, have been keeping that website nicely stocked with new materials. We have information about the book. We've got a photo gallery of some of the key figures and stories that are told in the book on the website. We have ability to navigate between that book website and the website for my previous books, and a playlist of debates and media appearances. And so if you're into this subject, in fact, I even have this video, once you guys do your editing and send it to us, will go up on a playlist we have at the returnofthegodhypothesis.com website for debates and, in parentheses, dialogues with those who differ. And I know some folks on this are on one side of the theist side and the aisle, and others are on the other, the atheist aisle. But we'll probably post this on this discussion there, because we love these open-ended discussions with people from different points on the ideological and metaphysical and religious compass. So if you're interested in this issue, I think you'll really enjoy the website, because we've got all kinds of content, op-eds, interviews, debates, and other background. I also have in a book this large, you inevitably find, or your readers find, errors that were made. So we've got a list of errata. If you all find anything that needs correcting, please email us. It will all get sorted out in the second edition, and we've got that posted on the website as well. So thanks.
Well, our guest again, Stephen Meyer, author of Return of the God Hypothesis. Thank you so much for giving of your time and for giving us answers, letting us interact, ask you questions. Thank you so much for being part of the club. Any parting advice for the atheists and the Christians alike in the club?
I say, keep looking for the truth, keep seeking, wrestle with the big questions. I love this iron sharpening iron discussion. It's the best way humans have of getting to the truth, I think. So I love what you guys are doing, and really appreciate the invitation to address you all, and to be able to see everyone. It's kind of cool technology, isn't it?
It really is. Thanks so much for being a part. And again, what we do at the Atheist and Christian Book Club, monthly gathering of believers and skeptics, respectfully discussing books. And we do both perspectives. So we alternate typically. We have a Christian book followed by atheist book. So we just had the Christian book, Return of the God Hypothesis. Next month, and this is going to be on October 7th, our guest author will be Bart Ehrman, and we're going to be looking at his bestseller, the Misquoting Jesus, and he's dealing with textual criticism. Is the Bible reliable? Do we know what Jesus said? We're going to be dealing with those issues. I want to encourage you to be part of that. Mark it on your calendar. And until next month, thank you so much for being part of the Atheist and Christian Book Club.